So far, we have seen what is Docker and what is the history of Docker and how does it help us and how it makes our life much easier than before. And we have seen the life before Docker and life with Docker, and we have created our own files after looking into the basics of Docker file commands instructions. Then we have built our own Docker images. Then we have run or spin our own Docker containers. And we have done a lot of projects and we had a lot of fun in each project. But my question is, who made all these things possible? Of course, it is not you. Not you, neither you nor your machine. Something else. Something else is doing these things possible. What is that? That's Docker. Obviously, that's Docker. But what part of Docker? What is there inside the Docker that it's making these things possible? So that's what we're gonna look into now. So we're gonna look inside the engine room. We'll look inside the Docker's engine room. So that means we're gonna look into the architecture of the Docker. Nothing else. We're gonna look into the architecture. So Docker architecture. So grasping Docker architecture is key to understanding Docker more fully. So in this slide or overall session, you will get an overview of Docker's major components on your machine and on the network. And you will learn some techniques that will develop this understanding more and more. So now let's jump into the Docker architecture. Let's enter inside the Docker's engine room and we'll explore each and every component of Docker's architecture. So we're going to start with a high level look and then focus on each component, each part with techniques designed to cement your understanding on Docker. So a Docker. So now let's take it. You have two portions of the screen. One portion is completely white box. So this is a private network. This comes under private network. This is your own network. And on other side, a light gray color is internet, which is a public network. Anybody can access this part. Okay. This is private. It's your own. Privacy is there. Here it's a public. Okay. This is clear. So now let's think. You have a host machine. This is your host machine on your private network. It could be EC2 instance. So my host machine, I'll show you now. Yeah, this is my host machine. I named it as a Docker server, and you can see that clear. Sudo I Docker help. You see that it's hosting Docker. So it is, this server is hosting Docker. So that's why I named this server as a Docker server, and this is my host machine. Similarly, you might also have a host machine in your private network. Here, this is a private network of EC2 instance. So anyway, we consider it as a private network. Others can't access my machine. Okay. So now let us split this into two parts. One part is Docker client, other part is Docker daemon. So Docker daemon is like a server. This works on client server architecture. So we have discussed and we have seen a lot of examples on this also. So your host machine on which you have installed the Docker. So that's the host machine will typically sits on a private network. So it consists of two parts. One is main is Docker client and other one is a Docker daemon. Now a daemon with a RESTful API and a client that talks to the daemon. So this slide shows your host machine running the Docker client and daemon. You can see that you have a Docker client. You invoke the Docker client program to get information from or give instructions to the Docker daemon. Through what? Through protocol HTTP and uh, TCP, under the hood TCP also. It doesn't possible only just HTTP. Okay, there are HTTP for TCP forward slash IP. It's a better way to put it. Okay, both protocols. Now, so a RESTful API, you see that this connection is made possible through a RESTful API is one that uses standard HTTP request types such as get, post, delete, and others to perform functions that usually correspond to those intended by HTTP's designers. So here let's look into this and we will jump into the our host machine and we'll see whether we have these things in our host machine or not. Okay, so here you see the Docker daemon receives requests and returns a response from the Docker client using the HTTP requests. Okay, so you have a client and server. So Docker daemon is our server. So now let's get into the um, our host machine. So this is our host machine. I will make it yeah, this is enough, I guess. This works. Yeah, let me clear the screen. Yeah, fine. So now what I'm saying, I will I will I will demonstrate Docker first. Okay, what Docker client first? What is, let's look into the Docker client. So where is Docker client? Can you tell me? The Docker client is nothing but a Docker CLI. So what is Docker CLI? So it consists of that software. The client consists of set of commands. So that if that set of commands are executed, so it's gonna communicate with the Docker demo. So I will show you the Docker client. So that what you see on the screen when I say Docker and help. So this is our Docker client. Okay. So through which it could be anything. It could be Docker CLI or it could be Windows PowerShell or it could be anything. So through that you are communicating with Docker daemon. So this command line interface, this CLI and those commands are called Docker client. So at this moment, whatever that I'm doing on screen using Docker command. So using this Docker command itself makes a client, a Docker client. You see that? If without Docker, if I give some exact same command, build, it's there is no such command itself. When you mention a Docker, so that's our Docker client. Now when I mention a Docker, then I can basically use lot of commands: build, run, tag, push, pull. A lot of commands I can use. Why? Because that's the Docker client. When I execute this will get communicated with the Docker daemon. But now I'm going to show you Docker daemon. So where is Docker daemon? So let me clear the screen. It is cd var ls. You will find the lib ls. You should see Docker, yeah, ls. This is the Docker daemon directory, data directory. This is Docker daemons data directory. But if you want to see the Docker daemons JSON file, it would be in etc. So cd etc and Docker. You see that ls key.json. This is a configuration file, a daemon configuration file. Okay, so let's get back to the var lib docker. and this is our Docker daemon directory. So here you can find everything, all. So runtime, plugins, images, whatever image that you create, all those images will be saved here. Networks and volumes. So you have two types of persistent data. Persistency can be achieved two ways. One is volumes and volume mount, and second one is bind mounts. This here you can use a volume mounts technology. And containers, all containers will be stored here. And overlays. This is like a databases to overall. So it stores everything. So this is our daemon. This is our daemon directory. So now when I execute, let's do one exercise before going to the next concept here. So let us do one exercise. I'll say docker pull just image. I'm gonna pull image and we'll see docker pull, it's cube charan mysql and version 1. So basically I'm giving a command using docker. When I use docker means it will become a docker client. Now when I execute this docker client will come, will tell docker daemon to pull this image from an external repository that we will discuss later, but at this moment you only see two things, docker client and docker daemon. So now, so when I execute this, an RESTful API request will go to the HTTP request, will go to the docker daemon, and docker daemon will come and act, and it will fetch or pull the this image, and we will see what's going to happen. Now I'll do ls and docker images. You could see one image, kubechar and mysql, and now I will go to the images, and you see that here we have overlays, ImageDB, ls, and sha. Yeah, here is the image. You see that image pull completed. No, docker images, where I have given. Okay, I'll give it here only, docker images. You see that CDF3 AA69F5 F0 and CDF3. So F3 AA69 F5 F0. So basically the docker daemon is the one which pulled the image and it has stored in their directory. So that's why I call it as a docker engine room. So more, it's a room, and most of the things will happen inside that, but the commands you have to tell her to do, you have to tell him to do this, you do that, you do that, you do this, you have to do that. And how that will be communicated, when we speak, when you speak to your girlfriend, it will be communicated either mobile phone or through message or through air or through many other. But here they use HTTP RESTful requests, RESTful API connect, or HTTP request and response. Okay, that's how it works. I hope you got the our understanding of this, a docker client and HTTP and docker daemon. So then you invoke the docker client to get information from or give instructions to the daemon. So that's what we have did it in our exercise. Then the daemon is a server that receives requests and returns responses from the client using the HTTP protocol. So now the server will accept requests from the command line client. That's what we have used, a command line client using Docker, and then so anyone else authorized to connect, whoever can give commands, so they can give commands and the Docker daemon will act accordingly. So now, So this is all fine. So the architecture is clear, inside the engine room is clear, but how this engine room will be connected with the external world, that is also important. Nah, see, if you just keep your engine room isolated, or your room completely isolated, where the power house is there, where the power is there, then how can you transfer this power to external worlds? How can you transfer it? How can you communicate with the external worlds? Only this will be completely isolated. If it is isolated, then what you can do? Isolated powerhouse is of no use. So how will you make that communication possible? How will you make that connection possible? So the daemon is also responsible for taking care of your images and containers behind the scenes, whereas the client acts as the intermediary between you and the RESTful API, nothing else. The client is not that important. Docker daemon is the powerhouse for us, and it does everything. So now, to communicate with the external world, to make that exchange possible, we need to have a registries. The daemon, you need to have a registries. Either you can create your private Docker registry, or you can go for the Docker Hub, a public repository or public registry. So whatever it may be, the connection remains same through HTTP request and response. So I will show you the private Docker registry first, and then we'll go for the Docker Hub. So a private Docker registry, let me go to the EC2 and click on ECR Elastic Container Registry. Here you can share, here you can store your images and share and deploy containers, a lot of things you can do. So here, if you see this picture first, let me make it much bigger. Write a code, this writing a Docker file, and then push that Docker file. After that, as a Docker image, build it as a Docker image, then push that into the Amazon ECR. Then once it is pushed here, then it will be compressed and versioned, tagged, and managed the life cycle. Then your image will be stored always forever, so with tags and all those things. So whenever you want, either it could be Amazon ECS or Amazon EKS or Amazon Cloud or on premises or some other cloud or whatever it could be. You can just pull it and build your container, and then that container can be pulled into any one of these options: Amazon ECS, Amazon EKS, Amazon Cloud, or anything. So that's the power of a registry. So a registry is a place where we store our images. Okay, so that if you want a private one, you can go for the Amazon ECR or Google Cloud or IBM. Every cloud has their own type of container registries to storing the images. So this is our, so now how to create that? Just go here and create a repository, and then whether you want private or public, we want a private one. Anyway, we are going to do this also in mega project, in Jenkins, in overall this iDevOps for you mega course, mega projects. In that we are going to do this. So private, and give the repository name, and create a repository, and you can start storing the images here. That's it. Of course it's not free, of course they will charge money. Don't worry. Nothing is free in this world other than my course. Really, nothing is free in this world. Even I am doing this course, like to use this Amazon web services and EC2 instances and various services in Amazon web services. I have to pay. I'm paying for the services of Amazon web service, and then I'm giving this course for free of cost. That's what I'm saying. That's why I'm saying nothing is free other than my course in this world. That's okay. Okay, let's get back to the work. Yeah. So yeah, private Docker registry. So this one, and obviously here also the Docker daemon only connects, not the Docker client. Docker daemon connects with this through RESTful API or HTTP request and response way, and then if it is a private, so or else you can do the same. You can do the same with the public repository. So public repository will be placed in inter network, not the private network. So this will be in an inter network. So in this case anybody can access that. So for this again, so let me show that Docker Hub also. So public repository is our Docker Hub. MySQL official image explore, I think yeah, see, this is a public repository or public registry. Anybody can take images from here. Okay, so and you can have another lot of other public Docker registry also. So the point of matter here is, the point I just want to convey here is, your client, the Docker client, calls up and instructs something to do for the Docker daemon. If the Docker daemon doesn't have that thing, then what it will do is it will immediately contact nearby or close by or known registries. Either it could be private Docker registry or it could be public Docker registry. If it is a public Docker registry, it's going to get from the Docker Hub. Private means you have to create your own and it will get it from there. And then once image has been fetched, then again Docker client says run it, then it will run it. Again the Docker daemon. But who is working, who is doing all these things? Docker daemon. And who is ordering to do? Docker client. And who is helping Docker daemon to do all those things? Private registry or Docker registries. It could be private or public. Okay, so the private Docker registry is a service that stores Docker images. These can be requested from any Docker daemon that has the relevant access. This registry is on an internal network and isn't publicly accessible, so it's considered private. And your host machine will typically sit on a private network, so the Docker daemon will call out to the internet to retrieve images if requested from the Docker Hub. So the Docker Hub is a public registry run by Docker Incorporation. Other public registries can also exist on the internet, and your Docker daemon can interact with them if it is provided a proper connection. So now let's demonstrate this thing one more time before we uh, go to the next slide. So what we're gonna do here is, I'll show you. I will use Docker client, and using the Docker client I say Docker pull some image name, then that will Docker daemon comes into the action and it's gonna fetch that Docker image or pull the Docker image from either Docker Hub or private Docker registry. So here we have only public Docker registry, so then I'll go for the Docker Hub. So from here to here to here, and it gives back, and then it will comes to the Docker daemon. We'll do this now. Let's get into the server. So I'll keep it like this. Okay, we will keep it this much only. I just want to show that that's the reason. So now let me say Docker images. You have one image that is MySQL. So now what I'm gonna do is I will use Docker client first. So Docker client, and using Docker client I'll say docker pull okay. So I gave this command. Once I give this command, so this command will be transferred through RESTful API using as a HTTP request to the Docker daemon. Docker daemon is our server. So now this Docker daemon is going to serve the request that has been made by the Docker client, but it does not have. So I'll show that. Wait. I'll move this little bit. Let me go up. Let me go up, more up, more up. Yeah. So here if you see, we are pulling it, so it is directly pulled from a remote repository, not from a local. We do not have that image on local. So then immediately what it has done, the Docker daemon has searched for the image. Anyway, we have given the repository name and after that the image name. So then it will directly go to that Docker hub and it will ask a Docker hub, it will request the Docker hub to send that image to that. Then again they use a RESTful API and HTTP request response. So it has sent that image. Now we can see that image. So all actions are done by Docker daemon. So now let me check Docker images. You see that? Here is that. Now again if you go to the cd var lib docker ls cd image overlay and image db content cd and cd sha256 and let me do ls, and this is the second image, the name, this is the second image. You see that cd yes, this is the old image and this is the new image. I will copy this. No, we'll do it here only. Docker images. You see that db564, db564, db564 and db564. So once it pulls that image from the Docker hub, it will store it in their directory. That is a Docker daemon directory, Docker daemon data directory. In that it will store. It's about image. So now we got the image, right? Now what I'm gonna do is, so at this moment we do not have even a single container. So now let me get into the containers first. ls, nothing is done. Okay, so let's spin a container from WordPress. So docker run, this will directly give without, okay, name is not required, and detached mode dp 8080, then I will give the name and it is WordPress v1 tag. So it's been created. Now let me say docker ps and you can see the container ID. Here now I am inside the containers directory. Now you see the same number 751A72C and 751A72C. Okay, so that's the Docker daemon is the powerhouse. Overall in Docker ecosystem, Docker daemon is the powerhouse. Everything works from there, but all will be connected and communicated through RESTful API using HTTP request and response method. So I hope you got the clear understanding, and before we close this, let's explore the Docker engine room. So what all components are there in Docker Engine room? A build kit, containers, we have seen containers, image, we have seen image, here network related overlays, plugins here, runtimes, swarm, Docker swarm related, TMP, rest volumes. So for us, the volumes is very important. CD volumes. So at this moment, okay, few amount of volumes are present, because metadata, okay, metadata dp is specific to Docker, so that anyway will be there, and this is backing fs block dev. And because we have spun two containers, one is MySQL, that's a database one, second one is a WordPress, so because of that it is there. So in addition to that, in other than this, we have a one more way. Main purpose of volume is, as we have discussed, if you want to have a persistent data, what is persistent data, we will come into that uh, in a few slides, don't worry. But for now, to have a persistent data, either you can use volume mount or bind mount. So if you go with the volume mount, so this is where the volume mounts will be placed. So let me clear the screen. So this is the architecture of Docker. So in this, so the key point to take from this Docker architecture is that when you run a Docker on your machine, you may be interacting with other processes on your machine, or even services running on your network, or the internet. So now that you have a picture, you have a clear picture of how Docker is laid out. And now we will introduce various techniques relating to the different parts of uh, this slide, or different components of the Docker ecosystem.